Okay, so in all statistical tests, we have to have assumptions because if we do not have assumptions or if our assumptions are violated, it's hard to make inferences about our population and we'll have biased data or we could possibly have biased data if our assumptions are violated. And in this case, we have values are independent observations. And in your walkthrough, it describes in more detail, thinking back about random sampling. And when the sample is an independent random sampling, it's when you select selection odds aren't affected by a previous selection. Thus, the values are independent where there is no relationship between them. And then the population is normal. Think back to a normal distribution. And you want to have that normal bell curve or as perfect as you can. And the skewness and kurtosis and other features are not too extreme. And so that's what you would be checking for a one sample t-test. We're not going to be checking for the assumptions today, but we will in later parts of this course. So let's go ahead and move on, and I'm going to just put a blank screen to the right because we don't need the written stuff right now. So we're just going to look at the PowerPoints, and what we're going to be doing is we're going to be making several other calculations. Not only do we want to know the difference, if there's a difference between our population mean and our sample mean, also we want to know how large is the difference, the magnitude of the difference, and that's what the effect size gives you. Is it a small difference? It may be a statistically significant difference, but is it a small, is it medium, or is it a large difference? And there's another way in which you can calculate the effect size, and this is R square. This is Cohen's d. We're going to use Cohen's d in order to interpret this treatment effect after looking at statistical significance, whether or not we have statistical significance. Now, this is something that we will dive into a little bit later, but just know that there are two different types of effect sizes that you can use, and we're going to be using Cohen's d. All right, let's say we go back to my original idea of group A not receiving the marijuana product and group B receiving the marijuana product, and we see that there is a difference between the groups when it comes to their artistic ability. Now you notice here that there is a difference, and maybe statistically significant difference between these groups, but this is pretty good art right here. And this is perhaps better, but it's not that big of a difference. So there may be a statistically significant difference, but is the magnitude of the difference large, medium, or small? In this case, Cohen's d is 0.15, which is about a small effect size, which is the magnitude of the difference is not very large. Now, in this case, we have the same experiment, and there's clearly a difference between these groups, and it is a large, or it's a medium, it's a medium, a little bit over a medium effect size difference between these two groups right here. So that just sort of illustrates the point that you can have a statistically significant difference between groups, but is it large enough to be meaningful? Or another way in which we can look at it is, how large is the difference? How big of an effect do we have? What is the magnitude of the effect? And this is very important when it comes to like medical research. So if you're doing a medical study and there really isn't that much of a difference between the treatment group and the placebo, the water pill that has nothing but just water in it, and the treatment group, which has the medication, if there isn't that much of a difference, that may be worrisome, because perhaps the treatment effect has a lot of side effects, and is it worth to have this treatment when there are side effects that go along with it? Now, another thing that we're going to be doing is looking at confidence intervals. And the way that we're going to be doing this, well, the first thing to notice is that it's capturing the range created around a particular parameter or statistic, and we're going to be looking at the mean. So does our confidence interval capture the mean, or the population mean within its parameters? And there's a way in which we can figure out whether or not it's doing that. We can have confidence that it is to a certain level. If alpha is 0.05, if it's 0.05, then we can say something about the confidence. Then we can say that we're 95% confident that the mean, population mean, is within our parameters. And I'm just going to write this out. So we have our sample mean, and then we have the lower limit of the sample mean, which is right here, and then we have the upper limit of the sample mean. And does this capture the population mean? And if I was to draw this out right here, let's see, which color do I want to use? I'm going to use purple. So does this capture the population mean? Not quite. It's a little bit under here in the upper limit. So it's like a net, and it's trying to capture the population mean within its parameters. In this case, we do have it capturing the population mean within its parameters. So here's the population mean right here, and it captures it within its parameters. Now, in our case, we're going to have 0.05 confidence. And so the walkthrough explains that in more detail. We're going to go ahead and move on. The one thing that we can look for when it comes to confidence intervals is an indication of statistical significance. So if our confidence interval crosses the 0 point, then that would indicate, that could be one indication that we do not have a statistically significant difference between groups. And in this case, let's say we have this SPSS output data, and we're comparing test to quiz scores, and we have a 95% confidence interval, and the lower limit is negative 0.608, and the upper limit is 0.03, or yeah, 0.03. And then in this case, it crosses the 0. So it crosses the 0 in a scale. So if we draw something right here, and here's a 0 point, and we have this lower limit right here at negative 0.608, and we have the upper limit at 0.063. Unfortunately, this is not in scale, but since this confidence interval, lower and upper limit of it, crosses a 0, it's one indication of non-statistical significance, or not statistically significant difference between groups. In this case, these two values, the lower limit in the confidence interval, perhaps it's right here, 1.6, and the upper limit, perhaps it's right here, which is 3.7, and here's 0 right here. The upper and lower limit are not even close to the 0 point, and so we have just one way in which to one clue or indication that there may be a statistically significant difference between our groups. Hopefully that is clear. And I wrote that right here on the slide as well. All right, so here's some of the steps that we're going to follow today. And this is in your walkthrough. I'm not going to read this word by word. You can sort of like make a screen capture of this a little bit later, or look at the walkthrough. But here is the data that we're going to be working with. Now, I'm using a slightly different set of data. I've changed the sample size and other features of this, but I wanted to give you an example to help you figure out the answers to each part of this problem set. And so I'm going to go ahead and end right here, and then look forward to see you in part 3.